Hi everybody, my name's Ali the Creator. Welcome to my small workshop. I actually tidied up. Usually I have two arms, by the way, but I bust my bicep. I forgot that I'm not 20 years old, so next time you'll see me with two arms here. I'm a case modder. I'm a functional artist. I'm an inventor. I'm a designer. I'm one of those crazy guys, you know, the crackpots who go around fixing things that are not broken. We call them case modders. Anyway, today I'm going to show you something else. I'm going to show you what I can do with one of these Speedy 100 Trotec machines. Thank you goes out to Trotec for lending it to me, for putting their trust in me. Now, before I show you something like this, or like this, or like this, or all the other machines which you can see at my website, creator.de, we're going to make a tool which I actually made one in the past, but I'm going to make a smaller one which fits better in my small home workshop here, and we're going to use the Trotec to make it. It's not one of these machines that would win a beauty contest like all of these machines have, but it's something that you can use if you're using one of these machines and you're actually cutting acrylics and plastics, because it's a Plexibender. So after watching the video, the plans are yours. Feel free to download them at the Trotec website or at my website. As far as the electronics are concerned, be careful if you're not an electrician. I'm also not an electrician, but I've done it a few times in my life. I've wired up a lot of stuff. Do get help from a professional. As far as all the materials are concerned, as you will see in the video, it's basically a Frankenstein, because I built it from different parts of different projects over the year. I didn't throw any of them little pieces of wood and chucks and things away, and I just used the laser to cut out all these leftovers and build this machine. So that's why it's very multicolored. It's got all the colors of the rainbow. You can build yours, of course, of whatever material you like. Just make sure that it's the thicknesses like in the plans, of course, unless you want to change the plans. And yeah, and then wire it all up, and you've got a Plexibender with which you can bend whatever acrylics you cut with a machine like this, like the Speedy 100. Thanks again to Trotec for putting their trust in me, and this is not the first project that you're going to see, but usually they're going to look much better like these machines here. Alright, so stay tuned. Well, as so very often, of course, every lasering project starts off with a file, and here you can see I am drawing in the measurements which I took and planned for the top board where you would actually put your plexi when you're bending it. The black patches, by the way, are going to be engraved, of course, as the color suggests, so that I can embed the hinges rather than putting them heightened up, because they do have a depth of about 2 millimeters, I think it was. And so the optics doesn't really matter here because it's a tool. To be quite honest, it's absolutely irrelevant. In this case, I think it's 10 millimeters plywood which I took. It's lasering off, or it's rather engraving the embeddable sockets for the hinges, and so this will be the top of it. Here you can see how I am just planning where the hinges are going to be, and of course the aluminium tunnel where the hot wire will be. The depth of the power supply which I'm using, thanks to Pierre for that, actually decides how high the whole trough or the draw or whatever you want to call it, the Plexibender is going to be. Took some measurements, of course, for switches and LEDs and the socket, and I decided to go with 6 centimeters, and the walls I'm making out of 5 millimeter MDF wood. Like I mentioned, this is somewhat of a Frankenstein, so this wood which I took is, I think it was 5 millimeters MDF. I used that just one board to cut out all the 6 centimeter high walls, which are all going to be just stuck with Elmer's glue. There's going to be hardly any screws here except for the hinges and things. Made sure that the sockets for the power input and the switch and of course the LED, everything found its place, and then it was just a matter of sticking them all together. They kept falling down here, so I had to glue them then afterwards, of course, as I was showing it here. But first of all, I put in the switch and the LED, made sure that they had their place. Here you can see some of the walls have already been stuck. And I'm not going to do much sanding or anything on this because it's basically a tool. There's no need to go overkill and make it look as pretty as can be, just like any of my case mods. It's just a tool. These woodchucks, of course, I cut them by hand, by the way. I didn't use a laser, that's why you didn't see them being lasered. But these are basically so that I can screw on the bottom floor afterwards. They're glued into place and they really are steadfast, so you don't have to worry about whether you want to nail or screw them. It's really not necessary. That glue holds like hell. And some of them I placed in such a way that I can actually stick the power supply inside and sort of slot it there. You can see that's exactly what I'm doing. There's going to be another couple of them on the sides as well, so that if need be, you should always be able to take the electronics out. That is maybe a rule of the thumb. You learn it over the years when you make a lot of electronic machines, that something always goes wrong. You forget a screw here, or you forget to wire something up and you want to take it out. So don't seal it, always make it accessible. So for the sake of fixing it in place, as you see, all I needed to do is make that little piece of woodchuck with a screw. Now I am drawing the bottom panel, if you like. It's got some air slits as well, so that the whole bunch of electronics inside there, which is basically just a power supply unit, I guess, can breathe in and out. And it's got a fan in as well. So placing some holes. Each one of them holes is actually going to place a screw over one of them woodchucks which we saw, and that's how I'm going to be able to fix it. And once again, of course, I took a different piece of wood. In this case it was 8mm, which I used. Like I mentioned before, this I could pretty much call this whole build Frankenstein, because it's just one of them typical little gadgets which I'm making out of leftovers from projects which I've been making over the last couple of years, and that just happened to be another piece of wood which was lying around. So once that was all lasered, took it out, and that is the back panel. It has its air inlets or outlets, and the holes which I need to screw it onto the bottom, onto those little white pieces of woodchucks which you saw. The next step which you see here is actually the holes have already been drilled. I'm just using the drill bit to sort of pilot the countersink in, because it is essential that you countersink the holes if you're going to place it on the top. You don't want to scratch the surface of a nice shiny table or anything, because you never know where you're going to be working with it. I am sure that I will not be just using this gadget at home building case mods, but I will be taking it to gigs, events, expos, and all sorts of live modding sessions which I do all over Germany, Europe, wherever. And because it's portable and it's never a problem to work with it, and I will be taking it with me, so I want to make sure that if I'm putting it on a conference table, for instance, or some table which just doesn't belong to me, that I don't scratch the surface. So the screws have to be countersunk. So the next step was, of course, to fix the hinges, and they are embedded into that engraved off black patch which you can see there, so that they are flush with the top of the table. After putting them in, that was when I could actually even start putting the tunnel inside, which will safeguard the wire and concentrate the heat in that tunnel, of course, so that we have heat in one line. I made a bed for it. I would probably design that part a little bit different. Maybe I make a fourth version of the Plexibender, and then that part will be different. But this is basically without making any real plans, so just working as I go along. So I made a rest for it and screwed that and glued that. Here I am taking off another 2mm layer once again for the hinges, but this will be of the top flap, the part which we actually flap over to bend the plexi. So this is the opposite part, just like a door stuck to the wall. The hinges will be in them black patches which are being engraved off, and it's, as you see, it is not the same width or depth actually as the actual base of the Plexibender, and there is a reason for that. which you will see when it's actually in use. I realized that when I made the first and the second version as well, that the less width I have, the closer the bends can be. So that top part is ready. I use my mini table saw to cut the aluminium tubing, tunneling, and that will be placed on that little rest which we glued on before. So the flap is on. I had to modify that rest a little bit, and that's why I mentioned before that I would redesign that part, but the files which you will be able to download will already be the modified files. So I needed some harder wood. I didn't want to take the poplar plywood which I was using previously, or MDF, because there will be screws in there which have to be adjustable. So I took some birch strips. I didn't need to turn the laser on for this. I just took my mini table saw and cut them to size. They'll be stuck on the rest left and right, as you can see right now, next to the tunneling, and that's where the guide screw, which is yet to be made, which keeps the wire straight in the tunnel, and the retention spring, because the wire expands of course when it heats, and of course the fixtures for both sides where I actually clamp the wires on will be. Taking harder wood is recommendable of course, because then you can screw in screws and take them out without actually severing the whole hole. Let's get that one right. The whole hole. Yeah, the whole hole. The complete hole, which will wear off, and the threads will be broken or worn off very quickly. So harder wood is recommendable there if you're going to use it for screws that you might want to screw in and out a couple of times. So after that, it was a matter of putting the tunnel or fixing the tunnel at the back in between the flap and the main board. I drilled the holes and then used a normal drill bit because I can't get my countersink in there. The tunnel is just not wide enough to countersink the holes, because that's important so that the hot wire will not touch the tunnel itself. Then I screwed it into place, of course, making sure that the flap and the top board are absolutely parallel with each other. I had to take my hand sander, as you can see, or grinder, and take off some of the heads of the screws from the flap, because I realized that they were a little bit too long, but I managed to sand them down and then they were flush. So that is just a decoration actually, what I'm doing right now. It's just a leftover piece of wood which I decided to put there so that the flap doesn't flap all the way down and stays more or less at 90 degrees. So it's just a support. Nice to have, don't really need it, but if you're careful with the machine then you wouldn't really need it. Now we are coming to a very essential part. You have to have a 90-degree wall, either at the top or the bottom. I decided to go for the bottom. So that you can rest your plexi or acrylic later on, and make sure that you have a clean bend and that it sticks to where it's supposed to stay. I took the chance to put my logo on this part, and I looked around what type of wood I have. I wanted to take either a piece of plexiglass or acrylic, or some hardwood, and I looked around and I thought I think I found some elder wood. 3mm I think it was lying around, left over from I think the Trilobite project which I made, and so I took that to make this wall, which I will just stick on, and then I'll screw it in afterwards. Main thing is that it's really perpendicular, really lying at 90 degrees to the hot wire, so that we get a clean bend. So once that was done, of course, then we come to a very crucial part, which would decide whether you get a clean bend or not. You will always get a clean bend, but whether it will be exactly where it's supposed to be and whether it's 90 degrees, that all depends on this wall which we are doing, or which we are sticking on now. I'm sticking it on so that I can make it exactly at a 90-degree angle with the tunnel. Which I measured out. Very, very important, because if it's not, later on when I put the screws in and they sort of push it a millimeter or half a millimeter back or forth, that would be very, very bad. Okay, after doing that, then I took 2 screws, I think it was M3, and I used my rotary tool. In this case it was a Dremel 3000, it doesn't really matter though, to make a slit at the top of the screw. Now this is crucial to keep the wire straight, so that it does not collide with the tunnel itself. I just made quite a deep slit at the top of the screw, so when I screw it in, then it will guide the wire on both sides. So I need 2 of them, and here I think I held it in the camera. Yes, I did, and there you can see that's where the wire will be guided through, so that it sticks in place and does not waggle around in any way. So the next step was, of course, to drill 2 sets of holes on each side, one for the guide screw with the slit, which we just saw now, and one to actually fix the wire. On this side at the bottom it will be a fixed screw, on the other side it will be with a retention spring, because of course the wire does expand when it's on and when it's heated up, and it retracts, of course, when I turn the machine off. So we need 2 holes on each side. First of all, I made a pilot hole, and that's why we have this harder wood here, the birch wood, so that I can put the screw in without ruining the threads if I have to put it, adjust it up and down a little bit to get the height of the wire on both sides absolutely uniform and at the same height. So I am screwing in the guide screw first of all, and after the guide screw it will be the wire screw where I actually connect it to the power supply unit. Alright, then once that guide screw was in, then I could actually place another fixing screw on the side, right down at the bottommost hole which I had drilled before. That's where I put in a normal wood spark screw and fix the wire to it. Here I am actually doing that, just took a little bit excess, of course. I didn't take the 30 centimeters which I need. I took about 10 centimeters on each side, more than I need, so that I can twine it around so that it doesn't come off while working with it. Threaded it through the tunnel, through both hinges, and that's when the second guide screw with the second slit comes into play, because after that will be the retention spring. So once that's in place, then I know exactly where that spring and that screw is supposed to be. It's just a little spring from a set of springs which I have. I attached the wire to it and made sure that it's always taut rather than slack. So then I pulled the spring as far as it could go to the edge, and and then I just screwed that screw in so that the wire is always under tension. So as soon as the wire will heat up later on, then of course it will retract, or expand actually, and it will retract. Let's reverse there. It will retract when I turn it off again. So it was just a matter of snipping off the excess wire there, which I used so that I could twine it around the screw, or around the spring in this case, sorry, so that it's not dangling around there, touching some of the metal part like the hinge or the tunnel. So, and here is a closer look at what it looks like. The retention spring, it's got plenty of space to pull the wire when the wire expands. On the other side, it's just a screw and a guide screw. The guide screws, like I said, are essential so that the wire stays where it's supposed to stay and doesn't hit the tunnel. Then I decided to make a test. I took a power supply unit from my old one, and before using the power supply unit in this unit itself, I decided just to see whether everything is still working, whether the wire is okay, how far it actually pulls the spring. Not that the spring is not strong enough, but everything worked out fine. The aluminium tunnel is not just there to safeguard the wood, because wood could burn, of course. In this case, it also channels the heat and keeps it in one straight line and does not affect the wood at all. I know that from the other two Plexibenders which I've built over the years. One of them is from 2014. and the other one which I made before that was in 2010 and is still in use by a modder friend of mine. So now we're coming to the part which I hate. Oh, I hate wiring. I can't tell you how much I hate wiring. It's just an evil necessity for every project, because nothing works without electricity nowadays, does it? So, and in this case, of course, we've got a hot wire which is resisting the electricity or the current, and that's why it glows and flows, and so it has to be wired up. So each side of the hot wire will be connected with plus or minus of 24 volts. In this case, this power supply unit can do up to 17 amperes. Of course, I have a switch and I have an LED and I have the power socket. So the power socket will be bypassing the switch, which has an LED also for 220 volts. And when the power supply is turned on, then the 24 volts will be sent to the LED as well, and then I know that it is actually on. So once again, I must stress the fact that if you are not good with electronics, you don't know what you're doing, please do get professional help, or get somebody over who can help you with the wiring and who knows something about wiring things up, because you shouldn't play with your life here. We're talking about 220 volts and they can kill you. It's not really rocket science, I wouldn't say that, but better safe than sorry. Anyway, so I will let you see how I'm wiring it up, but I'm not going in too close because that's up to you. Make sure that it's done properly. Once that is done, give it a test. If everything lights up and everything works, then you can screw on the back panel, of course, and that's what them white pieces of wood chucks were for. And that's why these screws are countersunk as well, so that they don't scratch the table, like I mentioned before as well. It is actually up to you what type of power supply you want to take. It should not be too strong that the wire heats up too quickly, and too weak that it doesn't heat up enough. I opted for this one, which I got from Pierre. Thank you, Pierre. But on with the Plexibender, which I made before, I took a normal notebook power supply unit. So the version 3 of the Plexibender is actually pretty much finished already. All I had to do then was make some type of clasp, so I took an old coat hanger because I don't want that flap, flapping around. As the name suggests, it should stay in place when I actually stash that the whole device, on a shelf or at the back of my workshop somewhere. I don't want the flapping around. So I bent some coat hanger wire, and that's how I made the clasp. So I don't really worry about my own workbenches, of course, but you never know where I'll be using this. And so, as I mentioned earlier, I took some felt pads and I stuck them on the bottom so it can easily slide along the table. I give it one more test, checked out some measurements, and I wrote the version line as well, so that I know exactly when I made it, because I've made so many projects over the years and I do like to document stuff which I have. So then I decided to make something which I always had wanted to add to my last Plexibender, is 2 jigs which actually fit onto the top board. And just help me to a certain level in making 90 or 45 degree angles. Of course, you can make these for 20, for 30, for 40, for 50. It doesn't matter. It's basically always the same type of fixture, but in the end, it just helps you to get that 90 or 45 degrees, which are the most common angles in my experience. First of all, they have to be very exact, of course, so that they really stick on and stay put. So I cut them out of cardboard first of all, just to check them for size. And it's good that I did that and didn't waste any of my leftover pieces of wood, because I realized that the 45 degrees, as you can see, doesn't fit. The 90 fit perfectly. So that's how it's going to be. Yep, 90 degrees is fine. I did have to tweak a bit on the 45 degree. I took off another centimeter, I think, and then everything was okay. So once I had tweaked that file, which you will get as it is, of course. Then I checked it for 45 degrees and it worked perfectly. So the measurements were all okay, and I was ready to laser these two parts out in, I think I took 10mm or 8mm. You'll see it will be noted in the files which you can download later on. While previewing this, I just checked it was 8mm. So yeah, just a matter of lasering them out. And but before they're going to be cut, of course, I have I don't know what I was doing there. I think I wanted to show you that little panel which I set into that little bay on the Trotec machine. I can switch the cameras back and forth. Something like an Elgato, but seeing as my name is Ali, it's an Aligato, if you like. Sounds Japanese, doesn't it? Well, that's basically where everything comes from, isn't it? Anyway, so I lasered them out, and let's check them and see that they are actually working, that they fit on. In the beginning, of course, it will be a little bit tough to get them on. I decided to, while I was designing, actually, you see they've got these sort of oblong holes in them. Those two pieces I'm actually going to stick on both sides so that it has more of a sort of a 90-degree flow on there. You can see I'm doing it so that they stay straight always. I put a little piece of paper underneath so that I don't actually glue them to the top of the resting board, if you like, and yeah, just glued them in place so that they will always stand at 90 degrees perpendicular to the top of the Plexibender. It wasn't very easy, I must say, building this because of my arm being in a sling at the moment, because my wrist and my fingers and everything are working, but I can't put any pressure on my bicep. But everything worked in the end, and that's how the Plexibender was built. So I guess it's time that I show you how this device works. Alright, then let's get to it. I'd like to show you the old one which I had before, which I made in 2014. It was also very portable, a little bit longer. It had a longer tungsten wire, and I actually did use it many a time at live events. It had a handle, and of course you have the external power supply, which I plug in here on the left, turn it on the right, and then I could bend my Plexi. I used it many times, and it's done me good service, but now it's time to move on to the new version, which is a little bit smaller. First of all, we will unclasp it with the self-made clasp from a coat hanger, open the flap, make sure that it's turned off first of all before you plug in the wire. It will convert 220 to 24 volts as soon as we plugged it in. There's the power supply. We turn it on, the LED is showing straight away that it's powered up, and you can see straight away how the retention spring is pulling the tungsten, which of course expands. Here we have a close-up of it, and now you can see why I made that groove in that screw to keep the wire parallel in 90 degrees, and so that it just doesn't hit the tunnel wall. Here you can see the wire, it actually heats up very, very quickly, so it's very effective and not too hot that it can actually burn your Plexi or your acrylic. I decided to make a 45-degree bend first, so I put my 45-degree bender helper onto it. You can see it stops the flap at 45 degrees. I've got a 90 degree as well. I took a piece of old plexiglass, or let's say acrylic, and I made a mark where I want it to lie on the wire so that I get my 90 degrees. The key thing is here that that brown piece of wood with my logo on the end, you can see you have to snap that piece of acrylic against it. Make sure that when you shove it on that it's lying adjacent or actually resting on that side so that you have 90 degrees. So once you've got it in place, then it is just a matter of waiting. First of all, I decided to time it the first time, and I came down to about 3.5 minutes. It's no good having a shorter time with a hotter wire because in the end you will just burn your Plexi. I gave it a try to see whether it's starting to get wobbly, and when it was at about, I think it was 3 minutes 40 or something like that, then I decided to make my first bend. Alright, so here we go. I made a little mistake there. I didn't push it adjacent onto so that it was resting on the top and the bottom, but I realized it straight away, and I just used my fingers to keep it in place. Speeding it up a little bit here so that you don't have to wait for the 3.5 minutes, of course, which it needs to cool down as well. Sorry, about 1 minute to cool down. And as you see, it starts to flap back because the acrylic was still warm. So I took my angle measuring tool and just made sure that I keep it at the 45 degrees, which I set it up to. And yeah, I mean, better safe than sorry. Measure twice and cut once, that's a rule. And here you can see that we have pretty much 45 degrees, so that worked out very well. Now let's give it a try with the 90-degree angle. Turn the machine off, of course, if it's still on. Take off your 45 degreer, put your 90-degree helper on, and then the flap will stop at 90 degrees. So here we go again. Turn the machine on, make sure that your plexi or your acrylic is actually stuck to or lying against the 90-degree helper on the right hand side. As soon as your time is up, about 3.5 minutes, then of course you make your bend. So bring the flap up. I'll speed this up a little bit because we don't have to wait for 2 minutes or whatever it needed to cool down. And as soon as that's ready, you can see it's trying to bend back because the outside of the curve is of course retracting again. So I took my 90-degree angle and just made sure that when it's cooled down I have 90 degrees. And as you see, it's pretty much perfect, so that worked very well. One thing that I would like to mention, of course, there is no rule of the thumb here except for different types of materials, brands, thicknesses, chemistries, densities, of course, have longer or shorter heating and cooling times. So make sure the machine is off and then unplug the wire. Once you've done that, then of course it's just a matter of bringing the flap down, and to keep it in place, use that clasp we made. Make sure that it doesn't flap around. Then it's basically just a matter of stowing it away. Unlike the one which I made in 2014, I don't have to pick it up and put it in a wardrobe or anything. Here I can just stand it upright, get rid of these angle parts which I made and the wire, and then you're good to go. It's in the corner and it will not disturb me when I'm working.